Hello, can you hear me?
Yes, yes, I can hear you.
Okay.
So today, not tomorrow. I have some work. That's why I make it today. So
No problem. It's okay. I
so
manage.
okay. So how you so first or the procedure what I want to uh, provide you today. I will give you basics introduction today.
Okay.
The basic introduction is divided in 2 days. As I told you that I am taking class on Saturday and
Saturday
Sunday.
and Sunday. Yep.
That's why I divided the class in two section. So today I give you a lecture of half part of basics, and tomorrow I will give you a half part of basics. Not tomorrow, sorry. Day after tomorrow
Okay.
on
That's
Sunday.
our Sunday. Yeah. Okay.
Yes. So how you will pay? How you pay the
Uh,
money?
I I'll pay the money Sunday if you
On
have don't mind it.
Sunday, half money you
Two
can pay
two
now.
forty 240 rupees.
You can pay 120
120.
today and
Then
120 that day.
okay. Then I'll send you 120 tomorrow. Okay.
Tomorrow, not today.
Uh, Today is it's night at this time. I'll send you
So how? Okay, okay, no
tomorrow
problem, no problem.
in
Okay, okay,
morning.
then fine, fine, fine.
Okay.
Okay, okay. Oh, you will pay, you will pay. So our this week money is final 240 rupees. You have to pay for till Sunday. Okay.
Okay.
Um, the Sunday class before Sunday class you have to pay 240 rupees. Okay.
Okay. Okay.
So now I started class for the this session. Wait, I will open my PDF and my software.
Are you starting share your
No,
screen?
no, no. I'm sharing. I'm sharing. Wait, wait. I have to open my some examples. That's why you have to wait little bit. Okay. Now I'm sharing my screen.
Hmm.
Uh, okay. Now you can see my screen.
Hmm.
Uh,
Yes, it's
because
shared.
today I am little busy. That's why I don't make. I am not making any. You can say uh, PPT. So
Okay.
that's why I make a PDF and I will tell you according to this one. Okay, and I'm making a whiteboard here. You can see this whiteboard for explaining the logics, and I will even help. I will make take help of uh, you can say the the manual also, because manual is you can say it's necessary for doing, and this is a deck build. And if you want to make a notes, then you can make notes from here itself. And also I will, if you need any PPT or other thing, I will share with you.
Okay. Then you can share it in Telegram. Yep.
Telegram. Yes, yes, I will tell in Telegram. So starting with the today's. So what is the need of atlas atlas, or you can say what is the need of this software?
What is
Because what do you think, why we need this software?
for modeling semiconductor devices or semiconductor semiconductor
So
devices.
why we need? So you know that before the software also there is fabrication is also there is a modeling of software is possible. But why we need this software, Silvaco as a software, or tcad as tcad software?
Uh,
No
I
problem, no
think
problem, no problem, no problem. I'm just asking
you.
you, okay, then fine. I'm telling you the cost of fabrication. First is if you want to fabricate a MOSFET,
Yeah.
let's say you want to fabricate a MOSFET.
Hmm.
Okay, Then
Okay.
you have to make a wafer which is extracted from the silicon, you can say sand of silicon, and then you have to clean, and then you have lots of infrastructure
Yeah.
to make that semiconductor to a chip, or you can say a MOSFET is required lots of things there. So that cause the cost which is very higher. And you know that
Cost
for the
of
simulation,
executions.
you,
Okay.
yes, that's why we need the software. And if the cost is higher, and you can see, you
If
can
you model it,
understand, like,
in virtual life, then it cost many much. That's why
no, no,
we.
yes, yes, yes. If we want to fabricate it in real world and check it, and it cost us a higher amount, because
Yeah.
you know that this is a like a feedback process. You have to check that we are getting a great result or not. Then you have to change your model. Then you have to change your model. Then this is a feedback process. So we can't judge the result.
Yeah.
Exactly. So that's why it is a cost of fabrication is higher here. And other
Cost
thing
of
is
materials. Next.
cost of material. And you know that you have done many of the, you have checked that simulation part, and the cost of material is the major issue, and you need to get the material from different source. But here you need no need to different material, you can easily define that also. And
Yes. The
time is
time.
also the main
Limited
thing. And
facilities.
limited facilities, you can say you need a very large infrastructure, and here you not need any large infrastructure. And you can do, this is a like a formality. I just add this one because I think it is a formality to start
There is no
any.
drawbacks. You added here.
Yes, drawbacks. I will tell you drawbacks also. You have asked the right question. Drawbacks is here is you can't judge the real world from virtual world. Virtual world means you can say you can't judge the any software software results as the real world result.
Yeah.
The result may be vary in the real world because you are just fabricating that. You can't take everything in that software.
Yes.
You just you get the some idea, and at that idea you are going to fabricate the things. So you can't totally level on the result of this simulation
Okay.
level.
Yes.
You can't. So that is the drawback here. And
Okay.
you know the 2D and 3D this is used for 2D and 3D also.
Yes.
Now come here, what we can do from this software. So you know that you have also studied in your, I think, in UG course, DCAC and small signal analysis, etc.
Yeah.
In your curriculum. I think you are from EC. I think electronics. I think
ET. I'm from
what is
ET.
what?
Electrical and Telecommunication Engineering.
So you have studied the DC, AC, and small signal analysis.
Yeah, TCSE. We know. We
Yes, yes,
have studied about
yes,
this.
yes, yes. So you know that for what is need of DC analysis and AC analysis.
Some of the courses are we have learned about that, but uh,
Okay, okay. No, 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 no. I will tell you. The DC is something, you know that DC analysis is used for.
direct
y-
current.
Yes, that is direct trend, but we need this is for, you can say, if you want some time constants, if you want some capacitance, not capacitance. Capacitance is not depend on that. The DC is used for resistance. You want to calculate resistance. You want a IV statistics. IV statistic. You have seen that. That is
Yes.
from the DC signal, and AC signal is used for, you can say, capacitance calculation.
Yes.
Capacitance, if you want to calculate capacitance, or if you want to calculate, you can say how gonna device interact at higher frequency. You know that power devices are act on higher frequencies, in 50 hertz frequencies. So how they
Yes.
gonna act like that? Drift diffusion model. You know that drift diffusion model is a basic model. You have studied that. And
Energy
the,
balance and
yes,
hydrodynamic transport model.
it is a very important model because uh, this model is energy balance and hydrodynamic transport model is a real world model. Actually, you know that there is a problem in drift diffusion model. If you can't understand, then I tell me. If you understand my what I
I have not learned about these models.
okay
I have to
okay
study
okay
on
okay okay
them.
okay.
So,
You know that drift and diffusion, drift
no.
drift.
Drip. I think I studied about this, but I forgot it.
Okay, okay, no, fine, fine.
I
Drift
will study
and
on it if you show me
I
this
will give you idea. I will give
uh,
you idea.
drip.
Diffusion. Have you heard this term before?
I think I heard it, but I cannot memorize that.
Okay, okay, no problem.
Okay.
So, um, the how you know that MOSFET how the MOSFET is working? MOSFET or you can say BGT.
Mm.
Not BGT. Like let's start with diode, diode. So you can say diode. So diode is working. You know the PN junction.
Yeah. PN
So
junction.
I will show you, miss.
Or some PN junction and get it.
This is a limited structure. So
P type and
I
N type.
yes, if a carrier wants to go from here to here, and another carrier wants to here go here to here, so that need a way that is our drift and diffusion.
Okay, that's
So
called drip
one more
diffusion.
thing, drift and diffusion is a very basic model. Very basic means that this is a very basic model means every device use that. And not every devices, every you can say a particular length device, a particular size device is using this model. And energy balance model is a practical model than the different diffusion model. Actually, I am giving just the brief idea. Actually, you will not going to use everything here. So I'm just giving the brief idea what we're going to study, or if we need this in our simulation. And lattice heating and heat sink, it is like a, hear the term
Yeah,
lattice.
that is. I know the
So
term.
device, how the device is working in the high temperature. So we also get from this Silvaco software.
Okay.
And another thing, create an abrupt heterojunction. Have you have
Hydro
heterojunction?
junction. No, no, it's not
Homo
known to me.
like you have seen the band gap curve, the balance band and conduction band. Con-
Conduction band, balance band.
yes.
Yes, it
Yes.
was known to me, but a heterojunction is unknown.
Okay, that is, then this is like if the conduction band and balance band is not symmetric,
Okay.
or not like a conventional one, then that is a heterojunction. I will show you one example here. You will know the heterojunction. This is like this. This is a heterojunction. Okay, or you
Okay.
can say understand this from this. This is the this is a heterojunction. Okay,
The
you can
lower
see
line.
yes, because yes, this is the heterojunction.
Okay.
This whole device is heterojunction, but I'm showing a particular this point by cursor. This is your
This
heterojunction.
kind of curves are called heterojunctions.
Yes, this cut six, this kind of band diagram, energy band diagram is called heterojunction. And the
Okay.
normal homojunction is like homojunction,
Homojunction. Okay.
not like homojunction. Yes, you can say homo and heterojunction. You can see here. See here. I will show you one more example here. Yes, you can see there. You can see here.
Which one?
Check
Homo and.
this. This is a homo, and this is a hetero.
Okay.
So
Hmm.
homo, what is particular about homo, and what is particular about hetero? Homo junction is like a like symmetric about the both the axes. You can see that not both the axes. I'm using a wrong word. I am saying that this is a conduction band, this is a conduction one, red one, and this is the blue one is a valence band.
Mm.
Okay,
Okay.
so you can see
This
that this is symmetric and this is symmetric.
symmetric. Okay.
Symmetric means you can say that the difference of energy band diagram,
Is
difference of
same.
energy band diagram here and here
Is
is
same.
same. Okay,
Yeah.
and now go come and now you come in the heterojunction. The difference here and here is different,
Yes.
so that's why it is called heterojunction, and that's why it is called homojunction.
Okay.
Many of the device you will going to face as a heterojunction, because heterojunction is making the characteristics better nowadays. Okay, so
Okay.
come now the optoelectronics and interaction with regenerated racings. It is like solar cells. You are going to see in the solar cells.
Solar cells. Okay.
Yes, and amorphous and polycrystalline material. You know that this kind of materials. Have you have?
Polyprodicyclic.
Yes, it is a normal material, symmetric materials. That is have symmetric in structure. I will show you in futures in future sessions, because
Okay.
this is a little bit higher terms. General circuit environment. You know that AC/DC likes environment, and emission and radiation. You are outside your home, I think.
No.
Sounds.
No. I'm in
Okay,
my
okay, no,
home,
fine,
but
fine, 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 fine,
the
fine.
outside noise is coming. Okay.
Okay, okay. Oh, no, fine, no, fine. I think. Okay, okay. So emission and radiation.
Uh, Stimulated emission and radiation. Okay.
Yes, yes.
I no knowledge about this.
Okay, okay, okay. So not heard this term. So that is like a something like a stimulated emission and radiation, like you can say like emission of electron
Radiation
and
we can see
radiation.
in the sun raw,
Yes, yes, like that.
sun
You
raw.
understand, you understand. Yes, that's fine. Yes, that is like Fermi direct and Boltzmann. It's a stats. You know that the dependency of ni the electron on the
Fermi
elect.
Dirac and Boltzmann studies this these are the laws, some of laws or
No,
something.
no, no, no. It is different thing. It is stats. It is not a law.
Okay.
Boltzmann's law, Fermi dirac and Boltzmann give a idea about how many electrons are going to go to conduction to valence band at
Okay.
particular temperature.
Uh,
At
okay.
particular temperature, you have seen the equation. I will show you equation here. Um, Boltzmann equation. I will show you. Equation.
We need to use
Uh,
this Boltzmann equation here. That's why we added this
uh,
term here.
no, no, no. It's stats. It's stats. It means we can use this model if we want in Silvago.
Models. Okay.
I will show you. I will show you. Wait. I will show you. Here it is not defined. It is equation. Oh, sorry. In uh in
Status.
device stats. Okay, statistical mechanics. Yes.
Statical mechanism.
Generally defined. It's this is a Maxwell distribution. Okay.
Okay.
You and this
Maxwell
is the
distribution.
you know that you studied in your courses, and you also study. This is a Boltzmann distribution.
Okay. We have to use this in this Silvaco.
Sorry, your voice is going.
You cannot hear me? Hello. Oh, lost your networks. Hello. I think your network is poor.
Sorry if my internet is going
Yeah,
down. Wait,
I understand. It's okay.
wait, my screen is. Can you hear my voice?
Yes, I can hear you.
Okay, okay, then fine. Sorry for क्या
No,
sorry for the internet issue.
no problem.
So by solving this equation, we get the
Mm, network. আমার নেটওয়ার্ক প্রবলেম আর নেটওয়ার্ক কি আমার আমাদের প্রবলেম নেটওয়ার্ক কার প্রবলেম নেই আমাদের নেটওয়ার্ক কার প্রবলেম সেটাই তো আমি জিজ্ঞাসা করতেছি পাঁচ মার্ক আমি ক্লাস করতেছিলাম কিন্তু আমার ডিভাইস ইস্যু করতেছে আমি তো হটস্পটই দিয়ে নাই আমি বকু ফোন করি আমি হটস্পট নিজের থেকে দিচ্ছি আমার সিমের কোথায় পাই কি রে খাইছি পাঁচ মার্কা গেল নেটওয়ার্ক আসছে গিয়ে একটু চেক করবা sorry my it was my network failure okay
sorry, 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 sorry. Now I also join here. Now you can see, hear my voice clearly.
uh screen
Uh, okay, I'm presenting it again.
okay
Wait. Now my screen is visible to you, I
It's
think.
presenting. Yeah.
Yes. Now, actually, this is the this is not much important here, but I am telling you because you have to deal like these statements in
Okay.
your project. So I'm going little faster here. So advanced mobility model is, here the mobility term.
Let's see.
Yeah, you have heard the term mobility.
Mobility.
Yes, yes.
I heard, but you discuss all this topic a little, just for
Okay,
my.
okay, no problem, no problem. Okay, mobility is something which gives the electron movement, how the electron is going to move, how the electron and the holes are going to move
Okay.
to convey the current.
Okay.
Doping, the hear the term, and now come here, and you
Doping,
hear
yes.
the term head.
Yeah.
Yes,
It's not me.
yes, yes. Then I will
Electromotive type dynamics.
wait, and this is the term, you can say. Oh, traps is not important here. I will tell you in future, and this is
What?
also not
What?
important. Contact is like a you are contacting the wire with the battery, like that. The wire which is contacting the device, something like that.
Okay.
Okay, and
Okay.
these SR, this is a recombinant model. I will tell you in future because you can't understand here. This is like a device physics terminology, and this impact ionization. It is also something different. I will tell you the floating gates. It is. I will give you example for this. In your pen drive, we use floating gates.
Pen drives.
Yes, floating gates. Not the device which is used to store the data in pen drives are based on floating gates concept.
Okay.
It may be MOSFET, it may be MOSFET, and it may be another thing. No, it is like a MOSFET. It is MOSFET. So that MOSFET is based on the floating gate concept. And I will tell you band to band and forward tunneling. Tunneling is something. In fact, I will tell you in I think in future. I told you that I am going to take a device physics class on next
In
Saturday
TFET,
Sunday.
I think this is needed band to band and floor. No.
Okay, fine, fine. But I actually, that you can't understand here because you we have to go with much more basics.
Okay.
So I'm going to take class on next Saturday and Sunday for the device basics, device physics, because today is your Silvaco basics, today and your Sunday, and the next Saturday Sunday is device physics basics. Then we will start with the project.
Okay.
Okay. And also your friends don't want to join. They
Uh,
don't want to learn.
Actually, I tell one of my friends, but he don't under, he thought that in online it's not trusted to anyone. That's why I don't
Okay, okay. Okay,
force
that's
him
why
to.
I'm yes, I understand that. That's why I took you the per class money. I'm not taking money and go out because you know that I'm going to lose 1200 money, 1200 rupees if I don't study you. You are going to lose if I don't I if I betray you. Then I will
I trust you. Then that's
yes,
all my own opinion. So
yes. Yes. So now goes to
that's what.
little further. There is no problem. You if you are going to 2 3 classes, then they also understand what I am going to tell you, how I am trusted or not. Okay,
Okay.
fine,
Okay.
fine. So
I trust
now
you.
okay. Also, I think trust issue is also yes, that's fine. I think at the end of class you have to pay money. That is
Okay.
fine. I think. Okay, that is fine. So you will pay me on Saturday for this class. Okay,
Okay.
and for Sunday and at the end of the class. Okay,
Okay.
fine. So management. Okay, no, that's end of that. So now I'm going to here. So this is the some effects which is I will tell you in device physics sensor, because you know that if I am telling going to tell you every fact in here, you can't understand fully, because that's depend on everything. That depends on electron, that's one holes. You have to understand from basics. So
Hmm.
you know that. So that's why
You are
this
just
actually
introduce me
actually
these terms. Okay, I
I'm
understand.
giving to, yes, I'm giving the brief idea what Silvaco software can do, what Silvaco Atlas software can do.
Okay.
Okay, now come here. Here, this is the most important part here. Atlas produce three or type of auto file. Atlas is the name of the software. Okay, Silvaco Atlas.
Silver
Okay,
Atlas.
the first type of auto file is an auto. This is like a this is explaining this term. What is this? So the David, the Athena, the Dagwood. Okay, the
Okay.
David part is the structure file. I'm what is structure file? I will tell you here. Okay, I will show you here. Some examples. I'm going to take some examples to show you what is the part of the that and what is part of this. I'll take an example of diode. Okay,
Okay.
fine.
That's example.
Okay, so this is basic diode. I will take a basic diode, which no, it's not showing basic one, but okay, let me take this one.
Shortkey diode.
Okay, see this. What I'm going to tell you. What is structure? Let is this is a code. Okay, I will tell you what is the code means and what going to this code. Even you know that even what this
Yes.
means. But I am going to tell you what is the structure file is like this. I remove this code and remove this code. I'll because I will just want to show you what doing this code. You can see that this is
Uh,
the log file.
log file.
But oh, sorry. Wait. I am doing something wrong here. Oh, sorry. Okay. I don't want to show you log file. Actually, I am showing you the structure file. Oh, sorry. My bad. Here. I am just want to show you a structure file. Okay. What is a structure? See this. Wait. Sorry. That is not error. That is due to the maybe some file saving error. Okay. Now this is
I
the
also it also shown to me that non-zero
in
status.
that case, in your case it is error. In my case it is not like that. You can see this is your structure file. This whole code give you a structure. This whole code give you a structure.
Okay.
Okay, so this may be from the Dagbuild itself, or maybe from the Athena is one more thing to make this structure. Athena is you have heard the fabrication process, about the fabrication process.
Yes. Yes. Here we can see the Athena process of simulator.
Yes, so you have heard the term how the device is mm, how the device is fabricated. Process simulator means what? It means that process simulator means that you have heard etching. Etching, have you heard this etching term?
Athena term I have heard, but the work of is I don't know.
Lithography. Have you heard the lithography?
Electrography.
Lithography.
Lithography.
Yes. I will
No.
tell. I will show you. Um, I have to show you litho. Uh, is it okay to see the example from the online?
It's okay.
Because okay,
Uh,
fine. See this. See this.
okay.
This is a whole process. This is semiconductor layer. Layer is something like we have to make the device. You know that the wafers is like pure
Yes,
semi
wafers.
silicon,
Yep.
pure silicon. We have to make their gate, their source, their drain there.
Yes.
So we have to make like we have to do process like etching, and you can say another process. So that can also we can done in Silvaku. Okay.
Okay.
And
Layering,
also they uh,
layering.
yes,
We can
you can
learn.
say layering. Yes, yes, you are understanding now. Layering it's like something layering. Layering of you want to layering of silicon, you want to boron, you want to doping of boron, you can do it in Athena. And David is like a mass editor and structure editor. David is you want to change in structure, you want to changing messing. Messing I will show you messing what the mean of messing. And now comes to this is structure file. That's why it's called structure because you have to deal with the structure. Okay.
Okay.
Now this is a deck build. I will show you deck build.
Okay.
Deck build. Okay. So deck build is used to the use of this structure as in the simulation. You apply the voltage, you apply the current, you apply the methods by which the calculation is doing. If you want to extract the curve is like IB cut 6. If you want to IB cut 6, like your my sound is clear to you?
Yes.
No problem. Okay.
Sorry for my noises.
No problem, no problem.
At
So
home right
now,
now.
so the device simulator and the output is runtime output, log file, and solution file. These are three
Hmm.
outputs. You will see in here. You have seen that. This is what? This
This
is a
one structure file, then log file, and
yes.
solution file.
I will show you
Which one
log
is the
file.
solution file? The lower part
Solution
of
file.
the dig build.
Not that. I will show in from codes here. Which one? This. Oh wait. I have to go for examples. That's why
Okay,
wait.
you can choose another one. No problem.
Yes. I will show you the what is the log file and what is the output file. This is your structure file. This is showing you
Structure file.
yes, the structure.
And the
This
carved
is your log file.
log file.
And yes, and the solution file is here. Solution you even get the solution file here also. Solution of the questions, or you
Okay.
may get solution file in the curve also, in the curve format also. So this is your log file. This is called your log file. Okay, even you see that dot log file. Log file contains the data that is plotted from the Tony plot. Okay, you are calculating the data. Okay, if you are calculating the data from your device, you are getting data. If you want voltage at, you can say that if your voltage at 0.2 is minus 11 is calculated from the calculation, and that is plotted here using Tony plot.
Okay.
You
Uh,
understand what I meant to say,
yeah, I
or
understand, but
you have doubt?
I don't understand the carve at all because
No need to understand the curve. I will tell you the curve,
okay.
why this curve is like this. But I am just want to say you the the purpose
I
of
am understanding
the
whatever
Tony
you are
plot.
saying. No
Yes.
problem.
Okay.
Thanks.
I will say I will deal with you that also because you are just dealing with basics. That's why I'm not
Basics.
dealing
Yep.
with that.
Okay.
Okay, that is log file, and this is Tony plot. That is visualize your Tony plot, and you have seen that I
Overall
have plotted
log
using
file.
Tony plot.
That means structure file and log file. These two
Yes.
things are also
Yes.
called Tony plot, included into Tony plot.
Yes. Yes, runtime output is not shown here. You seen that runtime output is here.
Okay.
You total time. Uh,
The
you can see here.
10.60.25.
Okay. And
Okay.
now come with this here. Now come with here. Hello. Stable here.
দাদু ওয়াইফাই আসছে কি? দাদু ওয়াইফাই আসছে কি? Okay. কই রে? নেটওয়ার্ক ইস্যু। হ্যালো। ওকে।
Yes.
ওকে।
Today itself is network error. I am have to complain with the network provider, but no problem. We have you have to little bit manage this issue
হুম,
for today because my internet speed is today low. You can see here. That's why. Okay.
it's okay.
So you can see my screen.
Yeah, it's shared.
Okay, okay. So you have to sort little bit minus. Okay. So this is something you can use dequelt minus as a command here. Here you can use the command even. Here you can see some commands is like that. So you don't have
Commands
to.
with the help of these tools. Okay.
No, no,
How
no.
did you
It is Unix commands and Windows command you can use in your system. Okay.
Okay.
No,
Okay.
that is not to need no need to I don't need to tell you because that is in Unix commands. Unix command is like you have used a command prompt system. Some laptop has Unix command prompt systems. That's there we you can use this as a way to open the outputs and input files. You have to use the input files. So here
S, why
in
you use S for unique command?
it's like a syntax. It is not you can say you can see here able to set atlas as a default simulator. So in Unix system, so I don't think you are using Unix system. So I don't
Mm,
think you are not
okay.
going to use this system. So that's why I don't emphasize here. Okay, fine. I wait. I will see my networks here. My internet speed is fine or not. Wait, I will see. It is not opening. Uh, okay, no, fine. You can see here also. Now
Mm,
coming here, running Atlas inside Barrack build. You have seen here. This.
go at last. Okay.
Yes. Also one more thing. This is the commenting way. Okay. Just you have to add this line. Okay.
We have to use slash for
Yes.
command.
Comment. And you write this comment here. And if you are going to this is not the comment.
Yeah,
This is the code. But if you want to comment, you have to add this.
I know that. Yeah.
Okay, fine. And now I'm telling you go address. So
Before starting the, any dig bill code, we have to write go at last.
if you want to use this structure,
Mm,
oh
the network was poor that time.
no problem, no problem, no problem. Okay, no problem. Even my one also is little bad today. So okay.
Okay.
So goatless is used for starting the deck build command. Okay,
Yeah.
if you want to open deck, this is a deck build. Okay, this is a deck build. If
Yeah.
you want to run the command, so you have to write goatless. Okay,
Okay.
Fine. And now coming to here, some codes are
Yes, yes,
in running. You if you want to add the versions,
okay, version.
oh, if you want to add the version of the deck build, this is the version of deck build.
It is necessary
So
to.
you can as like a same flags there.
Is it necessary to add these versions? Oh,
Yeah. You can hear my voice now?
yes, yes.
You can hear my voice now? Okay, okay.
I'm hearing
Why
you.
don't think why my internet is not running. I even don't know. Okay, fine, fine. Uh, now come here. In the this file, you are seeing the Simflex version. You can add the versions here.
Uh,
Okay.
is it necessary to add the versions?
No need to. You can add
Okay.
Go at less. So
Go.
they use the default version. So
Okay.
it uses the
Default
default version.
version is easy.
Okay, and also you can add the processor. This is a processor.
Okay. Process.
Like you have a device like you in your PC. I think if it is a you can say dual core, then they have four processor, and it has a octa core, then it's a eight processor. So you can use P8 here, but it is also no need because while using Go Atlas, you can they use the allocate number of the system want that allocated the processor. They assume that, so you don't need to this use this. Okay.
Hmm.
uh, if larger automatically reduce, so that is like that. So now come here.
What कबूतर से? Hmm, फिर से अटक गया.
Now come here, atlas index.
Okay.
Oh, you can see my screen.
Yes, it's shared.
Okay,
The Atlas
now
index.
yes, the atlas syntax. The atlas syntax is how you define the codes. Even you can see you can see here the code, the name,
Nash, regions, doping.
view, space, like this. So this is the way we define the code. Okay, that is that I want to convey you
Okay.
the
Statement
statements
parameter
parameter,
value.
and this is the statement parameter value is
Okay.
this. So now come. This is the order of the code, which I will. I am right here for you. So that's why I like tell her about the sort syntax. So I am also tell you about the source syntax. How you use source syntax. So this is the way the order of the code. Order of the code is like you can see here. They also define like first massing.
But
Okay.
all the codes follow the same rules of this area.
If yes, though no need to use this order everywhere, but
Okay.
if you use this order, you will always uh, get, you can say you are always avoiding the problems.
Okay.
Avoiding the problems means you don't know there's error in the way the you define the codes. So you, if you want to avoid the problems, to define like
We
this,
need to
because
follow
you
the.
can't define this statement below this. You can't define this statement below this one, this one, this one, above this one. You can't define like
Okay.
this. You can't define this one because this is a particular order, because
Order.
you have to define the structure, then you have to define the material, then you define the contacts or electrodes, then you define the interface. Interface means like you define the methods how to solve the calculations, then you define the what you want to extract the data, and then you want to define the what you want to plot. Okay.
Okay.
So this is the order. If you want to learn this like I'm read learn this like a I'm read. MMCI, MLSLS. Because whenever I use this software, yeah, I don't need to visit this manual every time.
Okay, you are expert in this right now, so you don't need to fo- show this further.
Fine, fine. Okay. So you can see this. So if you want to start some data, so you get the from here. And now come
Extract.
below.
Okay.
You have a question? Any question?
Uh, the how to use the extract before tonic plot. Uh, in the first program you showed me that is there any
Wait, wait.
extract command. আটকাই গেছে নেটওয়ার্ক ইস্যু আপনার use network problem 10 wireless router. I have that Rampur. Hmm.